In this video, we are going to look at how to name ionic compounds. So there's two things we want to be able to do. We want to be able to write the name of the compound if we're given the chemical formula, and we want to be able to write the chemical formula when we're given the name of the compound. In this video, we're going to look at how to write a chemical formula when we're given the name of an ionic compound. So before you start, be sure that you review your charges on your monoatomic ions and also review your polyatomic ions so that you know the charges, say, on our group 1A metals. Those are all +1. Group 2A, those are all +2. Group 7A, those are -1. Over here we have -2 charges, -3. And also appreciate that several of our transition metals have multiple charges. So again, be sure you review those and you're familiar with the charges on the ions. Also, be sure that you review your polyatomic ions. You need to have those memorized, the names, the formulas, and the charges in order to write the chemical formulas. So, when you are given the name of an ionic compound and you're asked to write the chemical formula, you want to go through a few steps. Don't try to do it all in one step. Go through this very systematically and you'll get the right answer. The first thing you want to be able to do is when you're given the name, you want to write the symbol or formula for the cation and the anion. So you want to write the symbol or formula and the charge for both the cation and the anion. Remember that the cation will always be written first. Once you write the symbols and the charges on the cation and anion, then you need to analyze the charges and figure out how many of the cations and how many of the anions you need to combine so that the net charge adds up to 0. Finally, once you've figured out the correct ratio, then you need to write the chemical formula and use subscripts to indicate the number of cations and anions that have combined into one formula unit. Again, the charge on the formula unit must add up to 0. So let's try one and follow these steps. Let's try to write the formula for barium chloride. So let's start off. We have the name barium chloride. So let's write the symbol for our cation and the anion. Barium has a +2 charge. Chloride has a -1 charge. Now, the second step, let's analyze the charges. Here we have a +2. Here we have a -1. We need those charges to add up to 0 for each formula unit. So we need 2 chlorides for every 1 barium ion in order to give us a net 0 charge. Now we write the chemical formula using subscripts. Barium, we have 1 of those, and the chloride, we need 2 of those, so we use a subscript 2 to indicate that we have 2 chlorides for every 1 barium. Now remember, when you're given a chemical name that contains a Roman numeral, we need to remember that the Roman numeral tells us the charge on the metal cation, nothing more. It tells us the charge on the metal cation. So let's try this one, iron 3 fluoride. Pause the video and see if you can write the correct chemical formula going through those steps. Okay, so iron 3 fluoride, the first thing we want to do is write the symbols and the charges on our cation and anion. Iron is a +3. How do we know that? Because we're given the Roman numeral 3, and that tells us the charge on the iron cation. Fluoride, we know, is a -1 charge. Now let's look at the charges, a +3 and a -1. We need to figure out the ratio. So obviously we're going to need 3 fluorides for every 1 iron in order to give us a net 0 charge for each formula unit. Now we write the chemical formula and we use subscripts to indicate how many of each ion we have. We have 1 iron for every 3 fluorides. Okay, so FeF3 would be the chemical formula for iron 3 fluoride. Now, we also, again, as I mentioned before, you must be able to recognize the polyatomic ions and know their charges. If you have a compound that contains more than 1 of a particular polyatomic ion, then you put parentheses around that polyatomic ion and the appropriate subscript outside the parentheses. So let's try one of these. Let's try calcium nitrate. Again, pause the video, see if you can write that, and then start it back and see how you did. Okay, so for calcium nitrate, let's write the symbols or formula for our anions and cations. Calcium has a +2 charge, Ca2+. Nitrate, we must know, is NO3 with a -1 charge. So now our second step, let's analyze the charges. Calcium's a +2, nitrate's a -1, so we're going to need 2 nitrates for every 1 calcium in order to balance out the charges. Now we write our chemical formula. 1 calcium and 2 nitrates. Because nitrate is polyatomic, we put parentheses and the 2 outside. So this means that we have 1 calcium for every 2 nitrates. So NO3, that is 1 polyatomic ion, and the parentheses and the 2 outside indicate that we have 2 of our nitrate ions. So let's follow those steps and try one more. Pause the video and see if you can write the chemical formula for copper 2 phosphate. Okay, so for copper 2 phosphate, let's write the appropriate chemical symbol and formula for our cations and anions and the charges. Copper is a +2. We know that because the Roman numeral tells us that our copper has a charge of +2. Phosphate is polyatomic, so we have to memorize that phosphate is PO4, and that PO4 has a -3 charge. So now let's analyze the charges and figure out the ratio. Each copper has a +2, each phosphate has a -3. So in order to get the charges to balance, we're going to need 3 coppers for every 2 phosphates. So 3 coppers, each with a +2, that gives us a total of a +6 for all of our cations, and the 2 phosphates, each with a -3, gives us a total of a -6. So our total negative charges are -6. So those add up to 0. Now we put them together in the correct chemical formula. Coppers, we need 3 of those, so Cu with the subscript 3. Phosphate, we need 2 of, and it's polyatomic, so we put parentheses with the 2 outside. So this would be the correct chemical formula for copper 2 phosphate. So pause the video and see if you can follow those steps. Again, don't try to write the chemical formula until you follow those steps carefully, and see if you can write the chemical formula for these 5 ionic compounds. Okay, so let's take a look at that. Manganese 4, that's a manganese with +4. Oxide's a -2, so the correct chemical formula would be MnO2. Aluminum is a +3, sulfide's a -2, so to get the charges to balance, we need 2 aluminums and 3 sulfides, Al2S3. Ammonium sulfite, ammonium is a polyatomic cation with a +1 charge. Sulfite's a -2 charge on the polyatomic ion, so we need 2 ammoniums for every 1 sulfite. So NH4 parentheses 2 SO3. Cobalt 2 iodide. Cobalt has a +2 charge. Iodide has a -1 charge, so we would have COI2. And potassium dichromate, potassium is K+, dichromate is Cr2O7 with a -2 charge, so we need 2 potassiums for every 1 dichromate, so K2, and then this whole thing here is dichromate, so K2Cr2O7. So practice some more of these, and every time you try to write the chemical formula, be sure you go through these steps. Write the chemical symbols and the charges for the ions. Figure out how many of each ion you need, and then write the chemical formula. Okay, so good luck. Be sure you practice a lot of problems.